Have you ever wondered how software systems are built using reusable components? Today we're exploring the fascinating world of component-based development, or CBD, within the realm of object-oriented analysis and design, often referred to as OOAD. This approach to software engineering is akin to building complex structures with Lego blocks. Each block or component is a self-contained unit of software, designed with a well-defined interface and built for reuse across different projects. This enhances productivity and reduces redundancy, a win-win in the software development world. CBD emphasizes modularity, reusability, and scalability, allowing for the creation of intricate systems from smaller, well-defined, and independently testable building blocks. It's all about building efficient, scalable, and robust software systems by assembling reusable components. So, if you've ever been intrigued by the idea of constructing software like a Lego masterpiece, you're in the right place. Now, let's dive deeper into the key concepts of component-based development. At the heart of CBD are components, the building blocks of software systems. Now let's delve into the crux of these building blocks: components and interfaces. Components are the linchpins of component-based development. Imagine them as modular, self-contained units, each encapsulating a specific functionality or a set of functionalities. They are like the Lego bricks of software development, each designed to perform a specific role, be it simple or complex. The beauty of these components lies in their independence. They can be packaged or distributed separately and reused across different systems or contexts. This not only enhances productivity, but also significantly reduces redundancy. But how do these components interact with each other? That's where interfaces come into play. Interfaces are like the rulebooks for components. They define the expected behavior and methods a component provides. By separating the implementation details from the user, they promote the principles of abstraction and encapsulation. Think of interfaces as a contract between components, setting ground rules for their interactions and ensuring consistency. Now remember the Lego analogy. Just as you can't fit a square brick into a round hole, components too need to fit together correctly. That's where the concept of compatibility comes into play. Components need to be compatible with each other to ensure smooth integration. And that's where interfaces prove their worth, providing a well-defined gateway for component interaction. But it's not just about building, it's also about maintaining. With clear interfaces, components can be easily updated, replaced, or maintained without causing a ripple effect on the entire system. This makes the system more resilient, easier to manage, and less prone to bugs. In essence, components and interfaces form the backbone of component-based development. They encapsulate functionality, promote reusability, and ensure smooth, predictable interactions between different parts of a system. So, components and interfaces are the fundamental units in CBD. But how do we put them together? That's what we'll explore in our next segment. Stay tuned. Composition is the process of combining these components to create a complete system. It's like assembling a jigsaw puzzle, where each piece, or in our case component, connects to form a larger, more intricate picture. In the realm of component-based development, composition involves integrating these individual components through their interfaces. Think of it as a symphony, where each instrument plays its part, contributing to a harmonious and cohesive performance. The beauty of this process lies in its emphasis on loose coupling of components. This means that individual components can be replaced or updated independently, without causing a domino effect on the entire system. Now, let's explore the concept of encapsulation. Picture a pearl nestled safely within an oyster. Much like the pearl, the internal workings of a component are hidden or encapsulated from other components. This promotes a clean separation of concerns, allowing components to be developed and tested in isolation. It's like having your own private workspace, where you can focus on your tasks without external disturbances. Encapsulation ensures that a change in one component doesn't send ripples throughout the entire system. Moving on to reusability, one of the key attributes that make component-based development a favorite among software engineers. Imagine having a toolbox, where each tool has its specific function but can be used in various contexts. Similarly, components in CBD are designed to be generic enough to be reused across different systems or projects. This not only reduces redundancy, but also enhances productivity by cutting down development time. It's like cooking with pre-prepared ingredients, where you can focus on the actual cooking instead of spending time on preparation. In summary, composition is the art of assembling components to form a complex system. Encapsulation is the practice of shielding a component's inner workings. And reusability is the ability to utilize components across various contexts. These concepts form the bedrock of component-based development, fostering modularity, scalability, and efficiency in software development. Now that we understand how components are composed and encapsulated, let's look at how dependencies between them are managed. In CBD, managing dependencies between components is crucial for smooth system operation. This statement rings true in the world of software development, where components often rely on each other to function correctly. So, what is dependency management, and why is it so important? Well, in the world of component-based development, or CBD for short, components are like the building blocks of a software system. Each component has its own unique set of features and capabilities. However, these components don't exist in isolation. They often depend on other components to function properly. This is where dependency management comes into play. Dependency management is like a grand conductor orchestrating a symphony of components. It ensures that all the components in a system work in harmony by keeping track of which components depend on others. It's like knowing that the violins in an orchestra can't play their part without the correct timing from the conductor. Now you might be wondering, how do we manage these dependencies? This is where dependency management tools come in handy. These tools act like a map, guiding software engineers through the complex landscape of dependencies. They track which components are dependent on others and help resolve any issues that might arise due to these dependencies. It's like having a GPS for your road trip. It tells you where to go, what turns to take, and even alerts you if there's a roadblock ahead. In the same way, dependency management tools help navigate the intricate web of component dependencies, ensuring a smooth build and deployment process. But why is this important? With proper dependency management, the likelihood of encountering errors during the build process is greatly reduced. It ensures that all components have what they need to function correctly, leading to a more reliable and robust software system. Moreover, it saves precious time and energy. Rather than manually tracking dependencies and resolving conflicts, developers can focus on what they do best, writing code and building innovative solutions. In conclusion, dependency management plays a pivotal role in component-based development. It's the glue that binds the components together, ensuring that they function as a cohesive unit. With proper dependency management, we can ensure that our components work harmoniously together. Now let's look at the benefits and challenges of CBD. CBD offers several benefits, from reusability to modularity. Let's delve into these benefits. First up, we have reusability. In the world of CBD, components are like the jigsaw puzzle pieces that can be used over and over again in different scenarios. This reduces redundancy and accelerates the development process. Then there's scalability. As systems grow and evolve, CBD allows for the easy addition or removal of components. Imagine being able to upgrade your car's engine without having to redesign the entire vehicle. That's the kind of flexibility we're talking about here. Maintainability is another key advantage. Thanks to encapsulation and clear interfaces, components can be updated or replaced without causing a ripple effect across the rest of the system. Next, we have reduced development time. By reusing existing components, developers can focus their energies on creating new features rather than reinventing the wheel. It's a bit like having a set of ready-made building blocks at your disposal. Improved quality is another notable benefit. With the ability to test components independently, we end up with higher quality software and fewer defects. It's like having quality control at every stage of the assembly line. Finally, there's modularity. CBD promotes breaking down complex systems into manageable parts, making the development process less daunting and more efficient. However, every rose has its thorns, and CBD is no exception. One of the challenges in CBD is component compatibility. Components need to be designed with an eye for integration into various systems. It's like trying to fit square pegs into round holes. If the components aren't designed with compatibility in mind, they simply won't work together. Despite these challenges, CBD remains a powerful approach in software engineering, enabling us to build complex systems from smaller, manageable and reusable components. In conclusion, component-based development is a robust method for building software systems. This approach utilizes self-contained units of software known as components, with well-defined interfaces. These modules encapsulate specific functionalities, promoting modularity and reusability across different projects or systems. By focusing on composition, the method allows for the creation of larger, more complex systems from these smaller reusable building blocks. Moreover, the principles of encapsulation and clear interfaces make these components easier to maintain, update, or replace without impacting other parts of the system. This leads to reduced development time, improved software quality, and enhanced scalability. However, it's essential to keep in mind the challenges such as component compatibility that come with this development approach. But with careful design and dependency management, these can be effectively addressed. By understanding and applying these principles, you can create software systems that are scalable, maintainable, and efficient. Thank you for joining us today, and don't forget to subscribe for more insightful content.